Hi everyone, thanks for coming to my session. I'm going to talk about Azure Functions, especially in version 2, what has changed from version 1. My name is Justin from Maxia, and I'm a double awarded Microsoft MVP. So in this session, first of all, I'm going to introduce in general what the serverless architecture is and what Azure Function is. Then I'm going to show how each function trigger works differently in version 1 and version 2. I'm also talking about how dependency injections work differently in version 1 and version 2. And finally, I'm going to show how Azure Functions instance can run in a Docker container. By the way, how many of you guys have been using Azure Functions so far? Yeah, based on the numbers, it seems this is still new. That's fine. This is an introductory session, so I'm not gonna dive too much details in this session. So if any of you guys wants to talk more about Azure Functions, please come and see me after this session. Of course, if you have any questions, just ask me during the session. So let me introduce Azure Functions and serverless architecture. So why do you think do you use serverless architecture, serverless or serverless applications at work? Can you tell me in what circumstances you are using serverless applications or Azure Functions? Yeah. So there are many cases. So we can't actually identify in what circumstances we can use serverless architecture. So let me tell you something. The serverless platform abstracts the server runtime environment. Therefore, we don't need to prepare the server environment itself, or we don't need to worry about how that sort of the platform will look like, or we don't need to worry about how the infrastructure can be set up. But we only need to focus on our business logic. And the serverless application is run by many different types of events. So if the number of events goes higher at some stage, the application goes automatically scaled out. So after some times later, if the number of events goes down, then the application automatically scales back in. So each trigger, each event triggers a function. So in other words, the serverless application only charges you when it is executed. So and the price is incredibly cheap. So every function is triggered by an event, like I said. So event can be anything, such as HTTP requests, or timer, or message, or whatever. But the more important fact is every function is stateless. So we can't use cookies or sessions, for example. So if you really want to use the function as a stateful manner, we need to introduce the Redis cache, for example, or data storage or database. Azure Functions support many languages, so theoretically it's language agnostic, but in fact it supports only certain languages because of current the limitations, runtime limitations. So out of the box, it supports JavaScript, C#, and F#. Recently, it started supporting Java as well. Even though they support Python, PHP, PowerShell, etc. They are all at this stage. They are all experimental. Azure functions run on top of the Azure App Service. Therefore, they are very they have many common factors between each other. But that doesn't necessarily mean Azure function is exactly the same as the Azure App Service. For example, Azure function doesn't support web.config or app-settings.json. So that's the only one example how the Azure function is different from Azure App Service, even though function is running on top of Azure App Service. Azure functions run on both Windows and Linux. At this stage, Linux is only supported by version 2, by the way. Azure functions support application insight out of the box. What we need to do is to just put an instrumentation key to app settings. Then the function app itself will take care of the rest. So I'm going to show you, or I'm going to start talking about how individual Azure function trigger works in version 1, and version 2. So the HTTP trigger, which is one of the most popular the trigger in Azure function side. So left-hand side is version 1 and right-hand side is version 2. So the difference is in version 1, as an input binding, the HTTP request message object is used. On the other hand, as an input binding in version 2, HTTP request is used. And output binding in version 1, HTTP response message is used. On the other hand, in version 2, IActionResult object is used, which input binding HTTP request and output binding IActionResult comes from ASP.NET Core side. Now, I'm going to show you how HTTP trigger works differently in version 1 and version 2. So this is my Azure portal. I'm going to click the version 1 function here. As the name suggests, this is a version 1 function. So I'm going to create an HTTP trigger here. So we can click and choose our custom function of HTTP trigger like this, and choose the language and create a function. This is how we can create as a function in the UI side. In the meantime, I'm going to create another function in version 2. So it says it's the version 2 function. Now, how we can create another one in here. HTTP trigger like this, and create a C# function. So it will be going to create it like that. So let me get back to the version 1 here. So this is the version 1 function. So as I mentioned here, it takes HTTP request message and it returns HTTP response message. That's how the version 1 function uses the input and output values. Now, when we run this exactly same here, so in version 2, it is using HTTP request and it returns IActionResult like this, right? So this is the rest of the logic will be exactly the same, but the only differences are the only difference is using different input and output object. So probably, yeah, you might be wondering how the Azure function determines if it is using if it is in version 1 or version 2. Let me show you about this. So if I set go to the function app settings here, and it will ask if we can use the runtime version. So if I can, the 1, which means version 1, and beta means version 2 at this stage. So once we change this beta, and we cannot actually revert back to version 1. If we really want, and then we need to create another the function app instance. Now we have created the HTTP trigger in version 1 and version 2 on UI side. Now I'm going to show how we can create the HTTP trigger through the Visual Studio, which is compiled one. Now I created two different functions here, but I'm going to create another one to how we can create Azure functions. So when I choose the Azure function project, and at the very first place, it will ask me to choose either .NET Core version 2 or version 1. So I can choose the version at the very first place. Right? So after that, we can use whatever we want. Now, I have already created a version 1 function here and version 2 function here. So I'm going to create HTTP function like this. So create function 1 and choose HTTP trigger. So in version 1, as I showed you, it takes HTTP request message and it returns HTTP response message. Now, I'm going to create another HTTP trigger on version 2 side. I create another one. Now, it is using HTTP request, and I action result as a return value. Okay, so so we can now build this and publish into the Azure function, right? So I'm not going to deploy this into too much details because it takes time. Now, yeah, so we just finished the how HTTP trigger works in the Azure functions, right? Is there any questions so far? Okay, so let's move on. Now, I'm going to show about the timer trigger in the version works differently in version 1 and version 2. Actually, there is not much differences between them. So the only hassle is for using timer trigger is sometimes we need to stop at the timer trigger, right? In that case, we have to use the function.json file and modify the value disabled equals true, right? So that also happens on to the version 2 side, right? But in version 2, there is another option to disable the timer trigger. So we can actually use app settings to disable a particular timer function. But it turned out that it is only applicable to the script type timer trigger function, not on the compiled one. I think that's a kind of the bug at this stage. So yeah, bear this in mind. So I'm going to show how the timer trigger works in the version 1 and the version 2. So let's get back to the Azure portal. So this is the version 1 function. I'm going to create another one, timer trigger, and use the C# and set up this value to run every 5 seconds. Right? I create this, and when we show this, when you see the log, and it runs every 5 seconds. It runs now, and in 5-second time, it runs again. Right? So if I want to stop this, I have to go and say disabled. Right? Then go back to the log side, and it won't be triggered again. Right? This is how the timer trigger is disabled in the version 1 side. Now, this time, I'm going to create another function on the version 2 side, so which is timer trigger. So I'm going to use C# function, and it runs every 5 seconds. Now it is created, so we can see the log file. We can see the log which it runs every 5 seconds. Now it is triggered and triggered again, right? So exactly the same. But if we disable this function, right, and it won't be running again as expected, right? So how can we ensure this? So when let's get back to the application settings. So when we run this up, open this up, so if you can see this, the timer trigger disabled is set to true, which means the function is disabled by adding this value into the application settings. So this function is not, as I showed before, this function is not running anymore. Right? This is how the timer trigger is working in version 1 and version 2, and how we can disable the version 2 timer trigger through app settings file. This is the end of the timer trigger demo. So any questions so far? Okay, let's move on. Now, this time I'm going to talk about the Cosmos DB binding. Right? So in the version 1 runtime on the UI side, we don't have to install any extensions because it all installed as a default. On the other hand, in the version 2 side of as a function, the runtime need to install the Cosmos DB extension if we want to run. But this is only for the runtime environment side. But if we really want to develop, write the function code in our local development environment, we need to install the NuGet package in both sides anyway. And as a default connection string name, it has been changed. So in version 1, it is using Azure Web Jobs document DB connection string. On the other hand, in version 2, it is using Azure Web Jobs Cosmos DB connection string. And our binding attribute class will, in version 1, it is using document DB. On the other hand, in version 2, it is using Cosmos DB. That's the difference. So I will show how Cosmos DB binding look like. So let's get back to the function again. So if I want to create another function in here, so I'm going to create another function using Cosmos DB trigger. So I have C# class here, and it calls it has the document DB connection string and collection name, for example, master, and let's say database name gap 2008, and yeah, like this, and I can create it. So this is how we create the Cosmos DB, right? And when you see that, it is using the document, right? So yeah, bear this in mind. And on the other hand, if I want to create a Cosmos DB trigger in the UI side, then it asks to install the Cosmos DB the extensions, right? So we need, if we want to use Cosmos DB trigger, and we need to install it, right? It takes time to install, like this, and yeah. So this is how we use Cosmos DB in version 2. So if we can use we can do local development in Cosmos DB. So I'm going to change this to create something. Now close this, and here in version 1 Cosmos DB trigger, and there is version 2 Cosmos DB trigger. So these are exactly the same as each other. For example, so it uses Cosmos DB trigger like this, right? With document object, right? This is the function 1, the Cosmos DB trigger, and this is the version 2 Cosmos DB trigger. So it uses same Cosmos DB trigger and same document, right? So don't worry about the name in here. It is actually using the version 2 Cosmos DB anyway. Right. So I'm going to I'm not going to publish this into, I'm not going to deploy this into the Azure function side yet, but I'm going to run this in our local environment. Okay, so let's run this on Azure function. So it is running on my local environment. So it is being running, and if I create a function, if I add a document in Cosmos DB, something like 1, 2, 3, 4, category is beer, and name can be anything, say Carlton, and price says 1, 2, 3, 4. So let's save this, and it actually takes it stops at the breaking point here and creates a document, right? So it creates a document, and it actually triggers the function, and it processes something like this. So this is how Cosmos DB trigger works. Okay. So the main difference is, as I said, is in function it uses document DB connection string in version 1, and it is using Cosmos DB connection string in version 2. That's the main difference. Okay. Now, this is the Cosmos DB trigger. So I'm going to show how Cosmos DB binding works now. Okay. So now, Cosmos DB binding. For Cosmos DB binding, I create an HTTP trigger for both version 1 and version 2. Right. So this is the version 1 thing, and when an HTTP trigger comes in, it actually its payload is stored into our Cosmos DB. Right. And in here, as I mentioned, in version 1, it uses document DB binding attribute. On the other hand, in version 2, it uses Cosmos DB binding attribute for output binding. That's the main difference. Okay. Now I'm going to run this into in our local environment. So first, build it and run this. Now I will put a breakpoint here. Then I will send a request to there. So I will create. I will send a payload look like the Cascade VR, right? And send it, and it will have a breakpoint here, and it will stop here, right? So I'm going to resume. Then it is stored into our Cosmos DB, right? And this is the one because I have already created Cosmos DB record through HTTP request, and the Cosmos DB trigger automatically picks up. Okay. Right. Now I'm going to check this here. So we created a beer, Cascade beer. So this is stored well. So I'm going to stop the demo right now. Okay, this is how Cosmos DB binding, input binding and output binding works differently in version 1 and version 2. Now let's move on to the Azure Service Bus binding. Any questions so far? No. Okay. So Azure Service Bus binding, which is basically the same. In version 1 runtime, extension doesn't need to be installed because it's default. As a default, it's installed. But in the version 2, we need to install the Service Bus extension, right? So Cosmos DB and Service Bus, we all need to install the extension in version 2. So what else? What else we need to install extensions? So there are many other extensions like Cosmos DB, Event Grid, Event Hubs, Microsoft Graph, Mobile Apps, Notification Hubs, SendGrid, Service Bus, and Twilio. Those triggers requires installing extensions on the version 2 side. Okay. And the main differences between the Service Bus output binding is in version 1, it uses brokered message, but in version 2, it uses message object. Okay, so I will show you how service binding looks like. Now, I created service binding object. All right. In the version 1, so I modified the Cosmos DB trigger in both version 1 and version 2. So what I'm doing now is whenever I create a document or I update document on Cosmos DB side, it will pick up and send a message to the Azure Service Bus queue, right? So in version 1, it uses brokered message, right? So it uses brokered message and to send on the message like this, sample and key. Okay, so and also it is using the memory stream in version 1. On the flip side of using version 2, we use message object, right? And it is using the message object without memory stream. Okay, so this is the main differences between service bus version 1 service bus trigger service bus output binding in version 1 and version 2. Now I'm going to build it and run it locally. So run this. So we are waiting for that, and I'm going to update. So let's say we change the price 1324. So it will pick up the change, and yeah, the change. Then it will send the message to the Azure Service Bus queue. So let's send it. So it is sent. So now we have Azure function, Azure Service Bus queue in here, and we have a message, right? And so we got a message like this, and the message has the changed value like this. Okay, so this is how the Service Bus output binding works. Now, so we have briefly looked at how each the triggers works differently in version 1 and version 2. Any questions so far? Okay, so let's move on to the dependency injection stuff. So in version 1 and version 2, we need to manage their dependencies if they have the logic. Yeah. So in a solid principle, the D stands for dependency inversion principle. So which means all the dependencies need to be injected outside the class, right? There are 3 different ways of dependency injection. So one is constructor injection, property injection, and method injection. So this is the how constructor injection works as a function side. But as a function has a starting modifier, which means there is no constructor, right? So constructor injection, we cannot use it. So the other 2 options, we still use it. So for the property injection, we define a static the property in a function class and instantiate the service locator in there and use that service locator, and we pull out the dependencies within the function method. In the method injection, we define the injector parameter. We introduce an injector parameter into the function method. That's the method injection, right? So if I am asked to choose either property injection or method injection, so which one am I going to choose? I would recommend using property injection because this is another the solid the principle. So O stand for open closed principle, which means open for extension and closed for modification, right? So let's go back to the method injection approach like this. So as a function team, probably write the function method parameters will look like, because let's say how the method parameter consists of. The method parameter consists of input binding, output binding, and logger, right? There is no injector in the design, right? So if I introduce injector as another extra parameter, that means it will break the initial design intention, right? So there must be a reason that they use the input binding, output binding, and logger. That's it. But if we use the method injection, we need to introduce another one, which, as I said, which may break their design intention, which is not desirable, right? So, which means it violates open-closed principles. On the other hand, if we use property injection, it doesn't break anything, right? It is just extending, because we only introduce a property and which is good for extension. Okay, so that's why I recommend choosing the property injection method approach. Okay, so unfortunately, in the version 1 Azure function, there is no dependency management out of the box. So we have to rely on the third-party IRC containers like AutoFac. So I will show you how AutoFac works within the version 1 Azure functions. So this is the module class that AutoFac supports. So within the app module, we register all the dependencies, like the HTTP client, and register it as a singleton. We register my own the classes as a type, something like this, right? And within the function trigger, right? Within the function trigger, we define a static property like container, and create a container builder, register module, and build. And within that, the function method, we just resolve the dependencies using container.resolve. Right? This is how the version 1, how dependency is managed in the version 1 with AutoFac. Right? Excuse me. Let's talk about the version 2 dependency management in this example. So version 2 is actually using ASP.NET Core, and ASP.NET Core supports built-in dependency injection method, right? So it comes with iService collection and iService provider, right? So, but we need to write our own container builder like this. So we create a container builder, and within the container builder, so the iService collection is instantiated, then register all the dependencies within the builder, within build method, and returns it the iService provider. Of course, we can create another method like a register module and register it instead of registering all the dependencies within the build method. We can separate it. So the HTTP trigger will be looking like this. So we define our static property of iService provider like this, and instantiate a container builder and run the build to return iService provider as a container. And within the function method, same as before, resolve all the dependencies what we want to use. Okay, so this is how the version 2 of Azure function uses the dependency management. Okay, and the benefit of using the version 2 of the dependency management is we can use additional configurations. So, for example, in version 1, we cannot use web.config or app settings.json, right? But ASP.NET Core actually supports those configuration settings. So we can use XML, we can use JSON, or we can even use YAML. Okay. So within the container builder and build method, we simply define configuration builder and add JSON file and build and deserialize the configuration settings and add that register that settings into the iOS container as a singleton. Yeah, that's how we can define the Azure function, define, or we can add configurations in our dependency management. Okay, but so as we see the function method, right? So we are using service locator pattern here, right? Which is basically an anti-pattern. So why is it anti-pattern? Because it doesn't show their intentions, right? So within the function, each function method need to express their intention, how it will be working, right? But service locator itself, it doesn't show anything, but it just resolves the dependencies. Okay, so instead of revealing, showing directly displaying service locator, we probably better hide service locator and show some intentions, right? Even though we are still using a service locator. So let's introduce the function factory, right? So if we define a function factory like this, and within the function factory, we build a container inside it, and when we create a function, right, through the function factory, then it returns actually the function instance like this. Okay, and this is my function. So within the function, I can directly use my own all the dependencies through the constructor, and we can invoke, we can run the function through the invoke method, and do anything whatever we want. And this is how the dependencies are managed within as normal way. Okay. So if we revise the previous the HTTP trigger, so instead of directly defining the iService provider as a static property, we just use define a static property with iFunction factory. Then within the run method, we create a function, right? And then invoke the method to get the result. That's it. So all the business logic has moved into the invoke method, and this is how the service locator shows the intention that we are going to run create a function, then invoke it, right? So now we have a function, right, with full testability. Okay, so I can show you how we can use the Azure functions to be testable. Now, so this is the test function. So when we see this, so this is a trigger and this is a factory. So that factory property takes a mocked object. So right, so this factory is mocked, right? Then so it gets all the mocked object, and finally we run the function with object the mocked object, right? So by doing so, the function entry point itself is fully testable. Of course, all the function method, all the function factory, they are all testable anyway, right? So if I run this test function and it passes, right? Yeah, it passes. Okay, so I just use the HTTP trigger as an example, but it can be used in any types of the trigger functions. Okay. Now, so any questions so far? Okay. I will now I'm now talking about the container, right? So Azure functions can be run within the container. So yeah, because it's possible on V2 at this moment. So version 1 Azure functions they don't support container, but in version 2 Azure function is supported by the Azure function version 2 supports container, right? Still this is in a public preview anyway. And this is possible because it is written in ASP.NET Core, which basically supports cross-platform, right? Which means it can run on Windows, Linux, and Mac, right? Currently, the container itself is Linux container, so the ASP.NET Core is running on Linux, and Azure Function version 2 is running on the Linux side, right? So current Linux container is based on Ubuntu. This is the only one at the moment, but I'm hoping that the other distros will be coming soon, right? This kind of nature actually has some kind of limitation. There is no consumption plan. So consumption plan only supports Windows at this stage. So if we want to use container for the Azure function, we have to use the app service plan for Linux for now. And as we mentioned, version 2 supports JavaScript using through Node.js and C# at this stage, right? Yeah, so it follows the normal the version 2 the Azure functions, right? And unfortunately, at this stage, the Azure Container Registry doesn't support Azure Function container, right? But we can use Docker Hub repository for to store the Azure Function container image and pull it from there. Right? This means we only use the public repository, right? So that's the current limitation. And so for the testing purpose, if we want to run the function itself, we can run it without a Docker container. Yeah, that's fine. So that's totally fine. But if we run a function within the container, right? That has to be each function has the auth level that has to be anonymous. We cannot use function. We cannot use admin, because if we set each function to be the function, if we set the function's auth level to be the function or admin, then it has to be deployed, right? Within the local container. If we run the Docker container in our local environment, that cannot be run because those function keys are tightly bound with the Azure subscription, right? So in order to test the function itself, then we can run outside the Docker container. But if we really want to test the function itself in the container, and that has to be deployed if we still want to keep the authentication level to be function or admin, right? So I'm going to show how the function as a function instance can be Dockerized, right? So I'm going to show the function. Okay. Okay. Let me show the function. So if I open this Visual Studio solution, we can see the container function app here, right? So I'm going to close those files and open the function container. So that's the very simple one HTTP trigger apps here. But there is another file called the Docker file, right? And in the Docker file actually defines which the based image it will be used, and how the custom, the container image will look like, right? So it's based on the Microsoft Azure Functions.NET Core runtime as a function image, and it sets up the www root as the root directory, and it copies all the DLL files from here to the root directory, like this. Yeah, we can put more details in our Docker file, but this is the bare minimum, right? So with this, I'm going to build this, and we can start from here. So I will open a Docker container here. So let's build the container. So this is the one to use. So I'm going to build a Docker container image. So it is built like this, and let's check the images. So in here, so I create the as a function container sample image like this, right? So if I want to run this, Docker, oh yeah, let's use this, which is much safer. So I'm going to run this, and then it will, yeah, it's running now. Now I'm going to how the container is look like. So let's go into the container itself. So all the bin, so yeah, we have bin file, and we have HTTP trigger in here. Okay, so if we go down into bin, and it has all the files like this, and if we go down into trigger, it has only function.json file, right? Like this. So this is yeah, so how it works, right? Now so what are we going to do now? So as we see here, so it is run in the 8080 port, right? So if we use 8080 port like this, and then send a message, then yeah, it returns, right? So because I have set this up in anonymous function, right? So, but if we actually really want to use the set the function authentication level to the function or admin, this will not be running. So it will return 401 error instead of 200, right? So in order to check, so how can we ensure that as a function app is running up and running? So instead of directly calling the HTTP trigger, just simply call the itself, right? So it is actually running like this. So as long as we can see that page, then which means the function application itself is up and running, right? Now, so we are happy that the container is actually up and running, right? Now we need to upload this one into the Docker Hub, right? Before doing so, excuse me, before doing so, we need to set something up, right? So we have created the Docker images, custom images, and then we need to tag that function, the container images, to be uploaded into the Docker Hub. So by doing so, we use the Docker tag, the command. So we use version 2, and we use version 2, and we tagged it, right? So let's see again. So we have the original, the container, custom container image that I just built, and then another container image with a different tag, right? And with this, and we can use this message. So this command will push that container image into our Docker Hub repository, right? Now we have pushed our Docker image, right? And then with this push Docker image, and we can create a function app like this, and that's about it. So let's create a function app with a different name. Let's say function app sample 3. Okay, so when we create it, and it will create the function app from the Azure CLI. So once it's done, it takes time. So it is created now, right? So let's go back to the Azure portal. In here, let's go back to the Azure portal, and in here, Azure containers. So it has container sample and container sample 3, which is just created, right? And if I click container sample 3, it will it takes time to ramping up all the runtimes, right? So in here, so it takes time. The sample test HTTP trigger, yeah, comes it right here. So it takes time, but this time it is much faster than before. So if this is basically the same, right? So yeah, so it only has the function.json file here, right? So once we create the Azure function app through the container, and actually that's basically the same as each other, same as the Windows version of Azure Functions instance, right? Nothing's major. Okay, so let's send a message to the function. So just use it. add parameter name, let's say Justin, and run this. And it takes time to ramping up. Right. So it works perfectly fine. Right. Right. So this is the end of the demo for Azure function running on the Docker container. Right. So it's almost there. So let's summarize it. So we have so I have introduced Azure functions and serverless architecture in general. Then what the difference is between version 1 and version 2 and how they are working differently, right? In a few the triggers. For example, the HTTP trigger, timer trigger, Cosmos DB trigger, and service bus bindings, right? And then we have discussed about how dependencies can be managed in different way in version 1 and version 2. And finally, I showed a Docker container running Azure functions, right? How we can create Azure functions in a Docker container and how we can deploy that container to the Azure to Azure. Okay. So, any questions? Right? So, yeah, as I said, I'm from Maxia, and we are hiring people, a lot of people. So, if you guys are interested in, please let me know. Yeah, so all the sample code used in this session can be found in my GitHub repository. Right? Yeah. Thanks for listening. My name is Justin. Thank you.